So, good day everyone. I am Prince Jerry R. Oidor, BCE 221, code 2221. And I am the one is being tasked to report about groundwater. Importance in civil engineering, or the importance of groundwater in civil engineering. So, in civil engineering, it is important to study the factors that might affect the project that is being planned to build. Factors that might cause your plans and projects to fail, postponed, or considered facts that will make the project more cost and etc. So today, I am going to discuss the importance of groundwater in civil engineering. But before that, um, I am gonna going to define first and discuss what is groundwater and its importance to environment. So what is groundwater? Groundwater is a water that can be found beneath the surface, where it occupies all or part of the void spaces in soils or geologic strata. It can also be found in the cracks and spaces in soils, sand and rock. It is stored in and moves slowly through geologic formation of soils, sand and rocks, which called aquifers. It is being said that more than 50% of groundwater in the United States is being used for drinking water, and almost everyone who lives in the rural areas. It is to be said that the largest usage of groundwater is in terms of agricultural purposes, such as watering plants, gardens, and etc. And groundwater also has importance because, just like what I've said a while ago, um, 51% of the total population in United States and 99% of its rural population use groundwater as their drinking supplies. And also, just like what I've said a while ago, it is also used in agricultural purposes, where 64% of groundwater is being used for irrigations in plants, crops, and gardens, and etc., which helps the production of our foods, and it is said to be the important integrant in many industrial processes. And groundwater also is the source of recharge for surface waters such as wetlands, rivers, lakes, and etc. In knowing the importance of groundwater in civil engineering, it is also important to know what is the branch of engineering that studies or focuses about groundwater and its behavior. And that certain engineering field is what we call um, groundwater engineering. And groundwater engineering is also in it's also called in terms of hydrogeology. So what is groundwater engineering? Just like what I've said a while ago, it is the branch of engineering that studies about groundwater. Groundwater movement, design of wells, pumps, drains, and etc. Groundwater engineering or hydrogeology is the study of movement and the dissemination of water both top and below the Earth's surface, as well as the impact of human activities on water quality and with problems in water management. Its main concerns includes groundwater contamination, conservation of supplies, and its water quality. So now, we are going to discuss what is the importance of groundwater in civil engineering. So in civil engineering, It is important to study and consider the groundwater since there might be some possibilities that it will affect the construction activities in Earth's surface. Civil engineering construction works or building construction plans have a significant impact on groundwater conditions, such as impact can range from the derogation of water sources by dewatering works to create the creation of barriers and pathways for groundwater flow formed by foundations or groundwater improvement processes. And later on, I will discuss what these impacts are. However, in such instances, not all these impacts are identified early enough during the planning and design process. The potential for some effects, such as the derogation of existing groundwater sources during construction, are usually taken into consideration. And to think about, groundwater can be viewed either in a way as worth protecting resource or a problem that requires a solution during beneath ground projects. Engineering use methods to lessen the effect of groundwater, and these might include temporary dewatering pumping or the construction of a physical separation wall into the aquifers and to prevent from flooding. Some large structures such as basement, road, rail cutting, buildings, and etc. might be equipped with permanent groundwater drainage system below the water table. Since groundwater is found below the Earth's surface, where it mostly located in soil pore spaces and rock formation fractures, the flowing of groundwater beneath the surface is important property that controls the toughness and compressibility of soil, impacting soil's ability that holds up the construction and structural loads. And because of these characteristics, it comes into something effect beneath the water table. Groundwater is a common because of the argument between contractors and owner in the construction projects. And now, we are going to know the impact of groundwater from construction works. A scope of permanent and temporary impacts on the groundwater environment can result from civil engineering works. There is no such comprehensive summary of these potential effects in literature, even though Powers and Thompson describe the unwanted side effect of temporary dewatering and impacts from mineral extraction. On the other hand, Prini and Brassington summarized the five categorized major potential groundwater impacts from civil engineering works. And these are abstraction, pathways of groundwater flow, barriers to groundwater flow, discharge to groundwaters, and discharge to surface water. So now we're going to know first the abstraction. So abstraction. Construction in permeable strata beneath the groundwater level have need of temporary groundwater control to let work be complete in dry and stable conditions. Such methods include the pumping from wells, sumps, well points, and etc. However, there might also be some impact or consequences to it. And these consequences are such: groundwater settlement that lesion of groundwater dependent features, effect on water levels and water quality in aquifers as a whole, and lastly, derogation of individual borehole or spring sources. And next impact is pathways for groundwater flow. These are some types of informal engineering construction of groundwater flow paths. Some might be temporary and can be sealed on completion, while others form a permanent part of structure. However, again, there are also some consequences of these pathways. And these are losing of yields when horizontal pathways reroute away from boreholes, increasing the risk of population in aquifers came from surface activities, the changes of water quality due to forming of pipe between different aquifers unit, and lastly, uncontrolled artesian discharge through a poor sealed site investigation or dewatering borehole. Next is the groundwater flow barriers. This is where extensive heavy-duty foundations are placed into aquifers, which are in a little depth or are of limited thickness. These concrete walls or groups of piles might interrupt horizontal groundwater flow, which will cause a damming effect. And the next impact is the discharge to groundwaters. There are construction activities that have the potential to create discharge through groundwaters with the risk of pollution and deterioration of quality of groundwater. Such common and such common examples are spills of fuels, leakage, lubricants that run off from operations such as concrete placement, and surface water runoff from topsoil excavation. And lastly is the discharge of groundwater to surface water. A temporary dewatering or long-term drainage system precipitate a discharge need. So it needs to be something that discharge the of groundwater. There are potential damaging impacts on the receiving water body, and these are erosion of banks to watercourses by poorly arranged discharge, which might also block or change the flowing pattern as scored materials is redeposited downstream. Next is suspended soils in the discharge water are highly visible, and also they are harmful to aquatic plants, fish, and insects or insect life. Next is oil and petroleum products might appear in discharge as a result of spills or leaks from plants, vehicles, or storage areas. Next is water which is abstracted from or near a contaminated site might require treatment prior to discharge. And the cost of long-term treatment could be major constraint on the value of construction project. So those are the impacts. And I also have here some examples of common ground issues during construction. So first example is unstable subgrade here. Next is the unstable excavation and water seepage picture. And also I have some common example. I have also example of common grounds problem after construction. And these are water leaks, wet basement, and mold growth. As you can see in the picture, there are there will be something water in basements, or it's just like um you just think about why there's your basement is wet, and that reason is because of groundwater. Next is crack and uneven floors. As you can see, cracked floors because of subgraded soil or the um, unstable soil. Yes, and it is most commonly um, caused into cracks and uneven floors. Next is the crack and uneven walls. It's also same with the crack and uneven floors because of unstable ground. Next is the unstable slopes and retaining walls. As you can see in the picture, um, we can mostly see them on such slopes area of projects. And lastly, the delayed foundation movements. So that's all. Thank you.